It's Sunday, 19th of January, and we are awaiting SpaceX's launch escape test in just under 17 minutes and 8 seconds. The test today is to demonstrate the effectiveness of our launch escape system. Now we are currently go for launch from pad 39A at Kennedy Space Center at 10:30 a.m. Eastern Standard Time.
Four, three, two, 1, 0. Ignition, liftoff.
Vehicles pitching downrange.
T plus 40 seconds into today's flight, all systems looking nominal for today's mission. Dragon on its way to the International Space Station for its 19th commercial resupply services mission. Coming up in about 20 seconds, we have max Q, our maximum aerodynamic pressure.
Perfect JSAT Group values the most as a satellite operator
is to be connected anytime, anywhere. We operate and control geostationary satellites at 36,000 kilometers from the Yokohama Satellite Control Center and 2 other control centers nationwide. We use geostationary satellites to provide stable communications in the air and sea. In order to provide prompt rescue and support during and after disasters, it is necessary to secure quick communication. Satellite communication is a big asset. In addition, we have partnered with low Earth orbit satellite operators, and from JAXA, we acquired small demonstration satellites. We will enter into the sensing business that collects and uses space data. For image analysis, we provide intelligence to make informed decisions in partnership with Planet Labs Incorporated, Orbital Insight Incorporated, and others.
Separation confirmed.
MVAC ignition.
Dragon, separation confirmed. Separation visually confirmed.
Spacecom's AMOS-17, a geostationary communications satellite which will provide internet, phone, and secure communications to customers in the Middle East, Africa, and Europe. On top of the first stage is the black carbon fiber interstage, and on top of that is the F9 second stage. And that's what takes the payload to its eventual destination in orbit. The stages separate at about 2.5 minutes into flight. The second stage has it in the fairing as the second stage continues on its journey to orbit. We will be attempting to recover the fairing halves tonight with our recovery vessel, Ms. Tree, formerly known as Mr. Steven. Our hope is to catch one of the fairing halves in the ship's nets and then recover the other half from the water with our other recovery vessel, Go Navigator. Our catch attempt will occur around T plus 45 minutes into flight, which will be after our webcast concludes, so we'll be providing any additional updates on those catches via our social media accounts. Lastly, the large truss structure that you see there is the transporter erector, or TE. That's what we use to hold to roll the rocket out to the pad from the hangar and then raise it to its vertical launch position as you see there. The TE also routes the vehicle's fluids, power, and telemetry umbilicals from the ground systems to the rocket and satellites until F9 goes on internal power and clears the pad.
Their online procedure. Now for Falcon 9, we've been loading propellant since T-minus 35 minutes. Falcon 9 uses rocket-grade kerosene, which we call RP1, for its fuel, and liquid oxygen, or LOX, as the oxidizer. It's that cold LOX that's causing the condensation clouds.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition, liftoff.
Vehicle is pitching downrange. AVI power and telemetry nominal.